In this video, we'll be giving a very basic overview of the SEER H 8.0 model with an emphasis on the electronics. Now, this is not meant to substitute training. If you have not done SEER H training before, or if you have never used the model before, it's highly advised that you do one of those and then watch this video. Now, as I mentioned earlier, this overview is going to focus on the electronics. The mechanical elements did receive an update, but most of those updates came in the form as either a parameter change or an additional parameter. The electronics, on the other hand, went through an overhaul, and we felt it would be beneficial to just walk you through some of the significant changes to better aid you when using the model. Now, the first thing you'll notice is that if we go to this work element section, you'll notice we have two types of electronics now. We have this top type without a border, and then we have this bottom type with the red border. Now, the one without the border is SEER H's typical electronic board estimate. This is what you would use to estimate the cost of a single electronic board. The one below that, however, this is used at an assembly level. So this is what you would use to estimate a box of electronics. You can give SEER information like weight, total printed circuit boards, and power, and it'll generate an estimate for you. Now, as you can probably guess, because you can't tell the model how complex the boards are or what type of boards they are, if you want a more accurate estimate, it's highly advised that you would do individual boards and then roll them up. However, if you're in a ROM stage and you only have the weight of the box, roughly the number of boards, and a rough idea of power, you can use this element to give you an estimate on what the cost would be to build that board. Now, if we go over to the parameter section, you can see that we've actually added a bunch of parameters, we've deleted a bunch of parameters, and it's well worth the time to go through them individually and read the help and find out what they do. This video will not be covering them all. We will only be covering the significant ones that we feel will take a little bit more time to walk through. And so with that said, we'll start off with the technology. The technology is very, very similar to how 7.3 and 7.4 use classification, in the sense that it separates the model based on the type of electronic it is. However, where technology differs from classification is technology also opens up what type of parameters are available for your electronics. So if we go to this top one, you can see currently it's set to controller. And if we look at controller and scroll down just a little bit, you can see we have things like major components, COTS modified components, minor components, external data rates, internal bus speeds, and input and output pins. But if we change controller to, say, an RF amplifier, you'll notice that the inputs have changed. You still have the first top three, but now you have operating frequency range, power, and gain. And so by changing the technology, not only are you reclassifying the electronics, but you're also opening up parameters that better reflect that electronics. So as a user, you can absolutely change this parameter. Just understand that if you change it, it's also going to change what inputs are required from you. Also note that any inputs that weren't on the old one are going to require you to put them in manually instead of using SEER H's default numbers. Now, going down to the next set of parameters, we are going to cover the complexity parameters. Now, these parameters directly relate to the outputs. So what you'll notice is if we scroll up on the outputs here, we have requirements capture. We have design analysis. We have design capture, and so on and so on. You can use these parameters to directly adjust that specific output. So if we scroll down to maybe documentation, and we'll scroll down on the outputs as well so they're lined up. Let's say you're working on a project that for whatever reason why it requires more documentation than what you would normally provide for this type of project. Everything else is remaining the same, but the documentation has a strict requirement. You can use this parameter to adjust that to better reflect the job that you have. And so if we look right now, we can see currently documentation is about 63,000. As soon as we hit OK, you'll see that it jumps up to about 126,000. And so by using that, we have changed just the documentation, but the rest of the things have stayed the same. Now, for obvious reasons, we strongly suggest that this be a last resort adjustment, especially since this requires significant judgment from the user themselves. It should really be a case-by-case basis where there's a specific need for it. However, one of the other things you can do with this complexity parameters is if you set it to VLOW, it will turn off that output. So using documentation again, if we double click on documentation, drop it to VLOW, and hit OK, you'll now see that documentation has been zeroed out. So you can also use these parameters to take out any type of outputs that you don't want SEER to estimate, and it won't take it up to the top. So you won't have to try to subtract that out in an Excel sheet later on. Now, the last thing I will mention about the parameters is if we quickly scroll to this, you can see that many of the parameters have been set to either nom or low nom high. For those who have used SEER 7.3 or 7.4 before, you'll probably remember that the platform would set many of the parameters. So one of the specific ones is if we go to certification rigor, which used to be certification level, this was set by the platform, and it used to have it so if you were a military air, it would suggest about a nom plus, and if you were space, it would suggest high. Well, one of the things we've done with the model is we have tried to normalize all the parameters to the platform. So if you are at a space environment and you see a nominal for that certification rigor, it is saying that this is the nominal effort for a space type mission. If you change it to a military airman and you see that nominal, well, now it's going to change the normalization, and now it's going to say that that nominal is nominal for a military air type mission. So it has it so you can leave it on nominal and know that this is the nominal position for your platform, instead of having to adjust it to a high to account for space or a medium to account for air. Now, going from the parameters, we're going to jump over to the schedule and quantities, and we're going to take a little bit of time to talk about the prototypes, because we've done some adjustments to the prototypes. Again, if you've used SEER 7.3 or 7.4, as you probably remember, to do prototypes you had to use a factor. So for something like a form and fit, you would have to put in, I think it was like a 0.65 to account for the effort involved with a structural prototype. And then for a full unit prototype, you would put in a 1. And then for a qualification unit, you'd put in a 1.5. Well, we've changed that. So now when you click on it, you actually get a drop-down menu, and you can decide what type of prototype it is. So you can just choose from a form and fit, a structural only, an engineering model, or full unit. Once you select that, you can also put a range on that. Now, if for whatever reason you're having a mix of prototypes, you can actually hit this non-recurring units next. If you double click on it, it'll ask for the next type of unit. So we did a full unit on the last one. Let's say for this one we do a structural only, and we're going to use 1, 2, and 4, or 1, 2, and 3. And what you'll see is it will just add the units, so you can clearly see how many types of units you have without saying, well, I have a structural unit, which is 0.65, I have a qualification unit, which is 1.5, and then I have a full unit, which is 1, so you add those all together. You can now very easily and cleanly have them separated and see them.
Now, the last thing I wanted to cover is the fact that the non-recurring units, they do not all behave the same. So if we look at the qualification units, for instance, you'll notice that there are two differences from a standard prototype. So the first thing you'll notice about a qualification unit is the fact that now it has its own line item You no longer have to do the calculations to figure out how much that qualification unit's going to cost you. It's now separately estimated by CRH. The other thing about the qualification unit is the fact that it now has the ability to affect your STO cost, or as it's renamed to, System Qualification SQ cost. Now, if you don't want it to affect your SQ cost, you can go to the parameter section, go all the way down to our modified using system level calculation. And if you click on the system level cost SQ, you can see that there is now this very unique option to allow qualification units to either affect it or not affect it. Now, this is not only a very unique characteristic to the qualification unit, it's also very unique to the system level cost. If we go previous to SMA, you'll see that it doesn't affect the SMA. We don't have that ability to say whether or not it's going to affect it. And the main reason behind this is qualification units are that final test to show it works. And so it will affect your system level qualification, but it may not affect much else because it's a final design. You're not redesigning it. So just be aware that some of these new units don't all behave the same. It's highly advised that you read the help and get a better understanding of what they do and what they don't do.
The thing we're going to discuss is the outputs. Now, what you've probably already noticed is that the outputs are significantly different than in the 7.3 and 7.4 model. We've deleted the peculiar support equipment. We've renamed things like program engineering to project engineering, and we've tried to break out the design to have it so it's at a lower level. And what we're hoping from this is for instance, for the design category, it's a very broad topic. There's a lot of things that are involved in design, and what we're hoping is by breaking it out, it's very clear and easy to see what the estimates are for those individual activities. We're hoping the benefit comes from that is that you're able to do a more apples-to-apples comparison, and also if for some reason why there is a difference between the model and your actuals, you'll know how to address it, or you'll be able to elicit our help a little bit easier and say, hey, look it, the model's working good, except for simulation, it's estimating too low or it's estimating too high. What's driving that? And then we can have a more concise conversation about it instead of saying, well, in the design, there's a lot of things included into it. So we're hoping this makes it clearer. We're hoping it makes it easier for you to use. So that actually brings us to the end of this brief overview. We hope this overview has been helpful and that it's been insightful. As mentioned, there were a number of parameter changes. We deleted some, we added some, we renamed some, but we're really hoping that the help we've put in there is clear enough to where it's able to give you a better understanding of what's happening there. As always, if you have questions or concerns, feel free to reach out to us. We always are ready to help when we're needed, and we hope you have just a great time using this model. Thanks.